All right, so we've talked about different types of consumers that we can imagine: risk neutral, risk preferring, and risk averse. And what we've seen is that the risk neutral consumers don't really take the risks that they face into account in their consumption decisions. Risk averse consumers would prefer to avoid risk, and risk preferers seek out risk. What I want to do is to look at what happens for each of these groups as they consume when they face risks. Um, and how that leads to insurance. And what we're going to find, just to sort of foreshadow here, what we're going to see is that since since risk averse consumers want to avoid risk, when they face risks, they're willing to pay something to eliminate risk. What do they paying for? They pay for insurance. And if you're a risk preferring consumer, since you get more utility from facing the risk, you're not so interested in purchasing insurance, but you might be interested in selling it. So let's take a look at how this works. So let's look at risk aversion and insurance. All right. So we have a risk-averse consumer. We'll assume that utility is square root of the payoff or income or the asset, whatever it is we're talking about here. And suppose we have a consumer who has an asset, and the asset's value is $100, but it may be harmed and reduced to $20. Okay? So you purchase something, you expect it to be worth $100, but it may lose value. And the probabilities associated with each of these outcomes we'll say is 0.2 and 0.8. So there's a 20% chance that the asset you possess will lose value. Let's find the expected value of the asset and the expected utility of the asset. So the expected value, 20 times 0.2 is 4. 100 times 0.8 is 80. The expected value of the asset is $84. And we can find the expected utility. The square root of 20 is 4.48. Square root of 100 is 10. Weight that by the probability. And we get 0.2 times 4.48. Let's call that 0.89. And 0.8 times 10 is 8. And so the expected utility is 8.89. Let's draw a picture of this. Okay. I found my straight edge, as you can see. This is a utility function that shows diminishing marginal utility. So I can draw the utility function this way. Let's see, we'll give it a nice curve to it. There we go. There's my utility function. And let's see what we've found. We have found that the value of the asset may be $100 and it may be $20. If the value is 100, then the utility associated with that would be 10. If the value was 20, then the utility is 4.48. The expected value of the asset is $84. There's another way to think about this. We have an asset with a value of $100, but on average, its value is 84. And so we can say that the expected loss of value, or the expected loss, is $16. Okay? Now, if I'm a consumer and I have a product, I have an asset, and I expect that on average it's going to lose $16 in value, it seems that I should be willing to pay at least $16 to protect the value. Okay, so there's a thing that we call an actuarially fair premium. Actuarially fair premium. And a fair premium is, in this case, $16. So the idea is that if I expect to lose $16, I ought to be able to pay an insurance premium of at least $16 to protect the value. Okay? Now, to find the expected utility, we need to use an expected utility function, which looks maybe like that. It's going to connect this point and this point, the $100 and $20 outcomes. And what our picture tells us is that at this expected value of $84, the corresponding expected utility is 8.89. Okay, so on average, the consumer ends up with an asset worth $84 and with an expected utility of 8.89. Let's take this and sort of turn it around a little bit and ask this question. If this consumer had a certain asset, that is, an asset whose value could not change, with a certain utility of 8.89, what would be the value of that asset? Well, if the certain utility is 8.89, then the utility function tells us that the certain value would be 8.89 squared, which is 79.03. Okay. Oops. So 8.89 equals the utility of a certain $79.03. So let's think about this. This distance right here, from there to there, represents the expected loss of value. Okay. If I'm an insurer and I write a policy on this asset, I can see that when the consumer comes to me with their $100 asset, I can see that there's a 20% chance of loss, and that means that on average the asset will end up being worth $84. And if this consumer wants me to reimburse them for any potential loss, then on average I'm going to be paying off $16 to the consumer, because 20% of the time I'm going to have to give them $80. For the consumer, this asset with an expected value of $84 gives them an expected utility of $8.89. with an expected utility of 8.89, they'd be fine having an asset with a certain value of $79.03. And so this distance is the consumer's maximum willingness to pay for insurance. So the maximum willingness to pay for insurance is, on the part of the consumer, the difference between $100 and $79.03, and that's $20.97. That's maximum willingness to pay on the part of the consumer. The minimum acceptable premium is the actuarially fair premium, and that's $16. And that's the minimum premium that the insurer will accept, because the insurer knows that on average they'll be paying off $16. So the question is it possible to find a situation where this consumer will purchase insurance? And the answer is yes. The consumer is willing to pay up to $20.97 for insurance. If they pay exactly $20.97, then look at what happens. There are two possible cases for the consumer. Suppose there's no loss. Then what they have is an asset with a value of $100. So their utility is going to be the utility of a $100 asset minus, if they pay $20.97, that premium. There's no loss, and so that's going to be the utility they get from having $79.03, and that's 8.89. Okay, so they pay $20.97 for the insurance. If that's the premium they pay, then they'll end up with the utility of 8.89. Suppose they actually experience a loss. Then their utility is going to be a utility of starting with an asset whose value is 100. Now they have this loss of $80. They also give up $20.97 because they purchased insurance. But because they purchased insurance, the insurer reimburses them for the $80 loss. That leaves them with utility associated with an income of $79.03, which is 8.89. And so what's happened is that by purchasing insurance, this consumer has gone from a situation with an uncertain outcome, $20 some of the time, $100 some of the time, to a certain outcome, $79.03 all the time. And so essentially what they've done is they have paid someone, the insurer, to take their uncertainty away from them and leave them with an asset that has a certain value, in this case, $79.03, or utility of 8.89. And so that's what insurance does, is it allows you to sell the uncertainty that you face to someone else who's willing to bear that uncertainty for you. Okay, and we can see that in this case, there is likely to be a market that works, since the buyer is willing to pay more than the minimum that the seller will accept. All right. What if we have a risk preferrer who faces a similar situation? So the risk preferrer has increasing marginal utility of income. So we'll give them utility of x squared. And suppose this consumer has an asset worth $10 some of the time and $2 some of the time. And the probabilities are 0.2 and 0.8. So we can find the expected value of the asset, which is going to be 0.4 and $8.40 is the expected value of the asset. And we can find the expected utility. The utility of x, 2 squared is 4, 10 squared is 100. We take the utility and weight it by the probability. 4 times 0.2 is 0.8. 100 times 0.8 is 80. And so 80.8 is the expected utility of this uncertain asset. So again, let's draw a picture. And in this case, the utility function is increasing marginal utility. So it's going to look something like that. There's utility, x squared is utility. All right. And so this asset could have a value of $10, or it could have a value of $2. If it has a value of 2, then the utility is 4. If it has a value of 10, then the utility is 100. The expected value of the asset is $8.40. And to find the expected utility, or to graph the expected utility, we need to control these, or not control, connect these 2 points. And so the expected value of 840 has associated with it an expected utility of 80.8. So let's see. Here's what we know so far. The expected loss, which is equal to the actuarially fair premium, is $1.60. Okay. The expected utility of the gamble, this uncertain asset, is 80.8. Okay. So again, we can turn around and say 80.8 is the utility of what certain value? Well, if we go all the way over to the utility function and then down, so the black is the utility function, the red is the expected utility under the gamble. If we take 80.8 and take the square root of that, we get 8.98. And so for this consumer, that distance is the actuarially fair premium, or the expected loss. How much would the consumer be willing to pay to make sure that they don't experience this loss, which is on average is $1.60? Well, with that expected loss of $1.60, they end up with a utility of 80.8. For them, in order to get that much utility from a certain asset, the asset's value would have to be $8.98. So the minimum acceptable premium for the insurer is $1.60. Since on average the consumer loses $1.60, the consumer has to get a premium of at least $1.60 to make it worth their while to create the policy. The maximum willingness to pay for the consumer is the difference between the initial value and the certainty equivalent value. This shows the willingness to pay, which in this case is $1.02. If the consumer pays $1.02, they get a certain asset that gives a utility of 80.8. That's the same as what they get under the gamble. If they pay any more than that, any more than $1.02 for the policy, then they're going to end up with a certain value down here, which will give them less utility than they get under the gamble. And so this consumer is not willing to pay enough to make it worth a while for the insurer to create the policy. And so there is really no insurance market here, since the consumer won't pay enough to make it worth the seller's while. Okay, take a break. If I can figure out how to stop.